Hey everyone, welcome to day 4. I'm excited to be here. Thanks for having me. I'm Ian Douglas. I'm a senior developer advocate at Postman, and I've been looking forward to having this chat for a little while now. So we're going to dive in a little bit. This is not going to be like a live coding type of tutorial. Instead, this is going to be a tutorial about different kinds of APIs. And of course, now my dog is wants to come say hi to everybody. But as far as like what the agenda is going to be for the talk, I'm going to give a little bit of background on the RESTful standards and where REST APIs came from. We're going to talk a little bit about event-driven APIs and then some low latency performance APIs. Lots of dad jokes along the way. I love me a dad joke. And of course, we'll wrap up after that. Happy to take questions as well. At the bottom of the slides, I've got my Twitter handle. It's the same handle also on Slack. So if you want to ping me with a particular question on the Slack, you can do at Ian Douglas 736. On Twitter, I'm Ian Douglas 736. I use the same name on LinkedIn, like a lot of platforms, you'll find me there. All right, so let's dive in a little bit. Let's talk about the most popular kind of API in our industry right now. So REST and the idea of what a REST API was defined back in 2000. RESTful is sort of a derivative of that. It came shortly afterwards because the REST standard by itself was quite rigid. And so people wanted a little bit of flexibility in how they did things. And so RESTful came shortly after that. And there's no real easy way to determine how we got the term like RESTful. But people didn't really like the strict rules aspect of what the REST framework was defining. And so a lot of schools nowadays are teaching about RESTful APIs, though it's mostly about the consumption side. How do we consume a RESTful API? But more and more, we're starting to see some schools, and we're saying this as Postman as a company. We're seeing more and more schools actually teach about RESTful API design as well. By the way, Postman has a student program where we work with a lot of schools to get students not just using the Postman product, but also just to do API education as a whole. So what does REST stand for? Well, it stands for representational state transfer. Sorry, words are hard this morning. So let's break that down a little bit. What does representational mean? Well, the way that you call an API is typically a representation of a resource and a type of action that you want to take on that resource. For example, you want to create data, or you want to delete data. The idea of state it comes from the fact that the HTTP protocol is a stateless protocol. Now, HTTP has been around since 1991. It's been around for quite a while. It started version 1. We're kind of overlapping now into where the world is starting to kind of get into HTTP 2. They're proposing HTTP 3 now, which alleviates some problems still. But the idea of state here is because HTTP doesn't remember from one request to another who you are or anything about your previous use of whatever technology is on the other end, whether it's an API or a website, anything like that. And so we kind of mimic the idea of this is who I am, or this is the object or resource that I want to change or manipulate in some way. And so we typically send these as ID values as part of a path or a query parameter or so on. And then, of course, the T of REST stands for transfer. And that's because RESTful APIs typically work on like a single request, single response. And so, I connect, you're going to transfer me some information, and then I disconnect. So REST, why is REST so popular in our industry? Well, growth really exploded back in 2005. Like once a lot of this flexibility kind of kicked in, we started seeing some really rapid growth, and it quickly outgrew other protocols that were popular at the time, such as SOAP. And so the idea of the data packaging was a little bit easier. SOAP was typically using XML, which is a very verbose way of transferring your data, but there's some trade-offs there. It also became quite scalable. It was easy to spin up what we call microservices and be able to bring these up quickly and scale these out on multiple machines. And then as far as the flexibility goes, using a browser as a client became really, really easy, especially when JavaScript really kind of dug in as the ubiquitous language, excuse me, within the browser. providing, the HTTP headers and so on, made browsers as a client um, a really easy way to sort of transfer things and make RESTful APIs a big part of the web that we see today. So for better or for worse, it was a lot of wild west out there with the RESTful APIs back in 2005 kind of era, because everybody was trying to define their own idea of what the standard could be or should be, and sometimes just within their own company. And that's where we get the term of governance in the industry. When we talk about APIs, you might hear the term governance. Well, what is governance? And that really has to do with how are we designing an API for our company so that all of our company APIs look the same, act the same, feel the same, and so on. So this is the other downside. I mean, well, it's a good thing and a bad thing about RESTful APIs. Is there are a lot of tools out there. Like, how do we choose which RESTful framework that we're going to use? Because there are so many to choose from. This is just a small sample of what I was able to find as far as building out a RESTful API. And I'm hoping I didn't miss too many in the list, but this should be a pretty unique list of the different technologies and different libraries in Python that you can use to build a RESTful API. There are plenty of derivatives where it's like, oh, this is our library, but it's based on Django REST framework, or here's our library and it extends something about the Flask RESTful library. And so there are a ton of derivatives out there. If you search the Python package index PyPy, if you search that for REST framework, you're going to get over 10,000 hits. Now, some of that is API clients as well, but there are a ton of resources out there to actually build a RESTful API. So it's really dug in. It's really, it's a very popular way of building out the APIs that we see. So some of these tools are going to help you define, like an open API specification, which used to be called Swagger. Swagger turned into a new specification. We called it Open API. They went through version 2. We're now into version 3 of the Open API spec. Some of these tools will actually take an Open API specification if you've already got that, and it will turn it into some starter code. Even Postman will help you do some of that as well. If you bring an Open API spec into Postman, we'll also generate some Python Flask code for you to get you started on actually building out the server side of your API. But this goes to show that the popularity of this kind of API, and for good reason. It's easy to use existing client software, whether it's the browser or the very popular request library in Python. It's really easy to kind of grasp the concept of how am I interacting with this? I'm going to connect to you. I'm going to get a single request and then the response, and then we hang up. So it's a very simple way of transferring data. So why look at anything else? As popular as it's been, RESTful APIs seem a little bit stuck still in HTTP 1.1 territory, which needs to kind of keep up with the rest of technology. So companies like Google started introducing new protocols several years ago, one of which they called Speedy, SPDY, which was later the basis of what formed HTTP version 2. And so the idea here with HTTP, because it's like you connect, you kind of go through this whole handshake process of this is who I am, this is the data that I want you to transfer me, the server sends that, and then you disconnect. And there are some things in here that are not great about HTTP 1. For example, when a client connects and asks for a single action, the server can't interrupt clients while the client is transferring data. And so if I connect to a server and say, hey, I want to send you some data, and the server's like, cool, I got you, bring it over, and I start sending gigabytes of data, the server has no way of saying, whoa, that's too much data. Let me pause you there because I have to handle all this data. The server literally has to wait for that whole transfer to complete before telling the client, hey, that was too much data, I can't process that. Meanwhile, you've already sent it, you've already paid for the bandwidth and so on to actually transfer that data, plus the time that it takes. So there are downsides to the HTTP version 1 protocol. And when it comes to inefficiencies around fetching data, when we build RESTful APIs, there's something that we typically deal with called underfetching or overfetching. And the idea of overfetching means I'm connecting to a server and asking for some data, and the server, because of the way that we develop our APIs, as developers, we're like, okay, well, we'll send you that bit of information, but we're also going to send just, you want that user's home address. Well, I'm just going to send you the whole user profile. So you get their name and their address and their phone number and, all this other information that doesn't need to be sent. All I need is their address. And so I end up stripping away a lot of data as the client, or as a client, the underfetch idea is like, I need some information about a user, and the server is so restrictive and so protective of that. It only sends a little bit of data, and I've got to keep going back to the server asking for more and more data. And every time I connect, I've got to go through that whole handshake of this is who I am, do our little secret handshake of authentication, just so that you'll trust me enough to send me that information. And then we have to disconnect. But the next time I need information, I got to go through that whole handshake process all over again. So the idea of the second bullet point here about like, can the server interrupt the client? The idea with this is like, this is on the fetching side of things, this is why technologies like GraphQL kind of came on the scene. It allows the client to determine, when I connect and I request some data from you, these are the fields that I want from these tables, but that does require that the client knows what's available to fetch. And you can get into the security aspect of, if a malicious user is trying to guess what kinds of fields they could have access to, then you can end up sending sensitive data. So you have to be very careful about how you build out your API. And, I could spend the whole day just talking about how to secure your API as well. So can we fix any of that? Like, can we move RESTful APIs to HTTP 2? Well, moving to HTTP 2 isn't just a software change in your API. It's a whole bunch of infrastructure that you have to change at a DevOps level that your team has to be able to support as well. So HTTP 2 is binary only. HTTP 1, when you connect and tell the server you want some data, you can do that data transfer either in plain text or in binary, but you can't do both on the same request. With HTTP 2, it's binary only. And so you can send your text over in binary format, get a response back in binary format, and your client and server software are going to know how to do that exchange. And so that does allow for more efficient transfer of messages. It also allows for better compression of data. And so when we send things over the wire, as we call it, we're able to compress that data a little bit better in HTTP 2. HTTP 1 does have a compression. Sometimes if you ever look at the user agent string of your browser, you might see the word gzip or gz in there. And that's basically indicating that, hey, anything that I send and receive from a server, I'm going to try to use this gzip compression. It's a very fast compression, but HTTP 2 has that compression built in. HTTP is still going to disconnect afterwards. Like I connect, we do a data transfer, we disconnect. There's no way to really push event-driven data. So like you're typically not staying connected with a RESTful API. And also HTTP 2 adoption is still a little bit low on the front end. So we'll get into event-driven APIs here in a moment, but with RESTful APIs and using things like the fetch library in JavaScript, fetch will support HTTP 2, but typically with RESTful APIs, they're not on HTTP 2 yet. And so most of these data transfers are still happening in text-only format, and you're sending things over in JSON format, where you can actually lose some visibility into the data type of what we're sending over. So if we think about how XML used to work over SOAP, XML, for example, was a very verbose kind of markdown language. But in that request and response, you could say, hey, send me this information. And the server would send it back in a package of XML that said, this field is a string, this field is an integer, this field is a floating point number, or this field is this kind of data. With JSON, it's just, here's your data. And it's up to the client to kind of interpret, like, does this look like a string? Does it look like a number? Okay, it looks like a number. Is it an integer number? Or is it a floating point number? And so there's a lot of extra work that has to happen around decoding and using that data. So let's talk about event-driven APIs. So there are a lot of things that we can do here where we get into things like automation and webhooks and so on with asynchronous calls. So the idea with event-driven architecture is kind of like, if this happens, then do this other thing. So you have a lot of choices on how to work with these event-driven APIs. So the sample code that you see on here, I took from the Async.io documentation page from like the Python documentation. And it's going to show you how we can use what we call the await, which is the asynchronous wait on here. So there are two ways that we can interact with event-driven programming for things like webhooks and so on. The first one is doing asynchronous clients, and the best example for that is what we call JavaScript promises. It basically allows an event loop to get notified when something is done. And so you connect to the server and say like, hey, like send this over whenever, that's fine. And you kind of put it in the background, and there's a loop that's constantly going back and checking, did that server respond yet? And if not, then I've got other work to do. I've got other interactions to take care of, the users clicking on buttons and doing other things in JavaScript. But all the while it's going back and it's checking this event loop saying, did the server respond? If so, then I'm going to handle that. So that's one way that we can do things. The other way is to say, hey, instead of putting it on an event loop and I'm going to check back periodically to see if it's done, we're going to use await, where we're saying, no, I'm going to stop everything else that I'm doing because I have to wait for this to come back before I can do anything else. And so these are just a couple of examples of how we can interact with that. So when it comes to things like webhooks and so on, where do we see these asynchronous APIs most commonly used? Well, for example, if you're reposting something into Slack, like if you're writing a Slack application, or if you're interacting with other types of servers like Discord, or even some APIs out there like PayPal, you can connect over a WebSocket and say like, hey, let me like go ahead and ping me back whenever somebody makes a payment. And so you kind of open and establish a long duration connection to the server, and the server is just going to send an event over that connection. So it would be like, being on a phone call with somebody and saying like, hey, I'm just going to stay on the phone. Tell me if, something happens in your neighborhood or something like that. And, something happens in the neighborhood and the person is still on the phone going, okay, yeah, something just happened, and you can do that data exchange. But that also holds that connection open. And there are limitations on holding these connections open because you're kind of reserving some bandwidth, you're reserving some resources to constantly have that connection open. Now on JavaScript, fetch calls are typically going to use these as well. And it's really great for processing these responses whenever they happen. So JavaScript promises started getting very, very popular for handling these things as event-driven APIs. Really handy for what we call eventual UI UX patterns, because eventually something's going to happen and you're just going to, JavaScript takes care of that event loop for you. And you set up a callback function that says, hey, if something happens, go call this JavaScript function and interact with the data that comes back. So you've got a lot of choices here. We've got things like webhooks, WebSockets. If you're using GraphQL, you can subscribe to what we call GraphQL subscriptions, which is also kind of a long duration connection where it'll send things over. We also have what we call server sent events, which can also play into this event-driven architecture. And even some methods of what we call pub/sub architecture will all be event-driven. So how do we build these? Well, in Python, I did want to grab some Python code here because I love working in Python. And so I actually grabbed this from the WebSockets documentation. This is how quickly you can get up and running with a WebSockets server. So a couple of lines of code, basically you're using that async IO module again, and you're basically, this code here is basically just going to build an echo. Anything you send to it, it's just going to send it right back to you. So we've got a main function in here that says, hey, go serve this up on localhost with a port, and then it's running this future call, which basically just says, just run this thing forever. Inside of that, then when you connect with the WebSocket, the client would say, hey, I want to call this echo endpoint, and it sends a payload message over. And basically the code that we see here is like, for every message that we get over the WebSocket, I just want to turn around, I want to send back that same message back to wherever I got it. And so it's a great way to just kind of echo these things back and forth. And so this is the fastest way to build a WebSocket server. The client code is just as small. It's like really, really tiny. So it makes it really quick and I don't want to say simple per se, but it's very straightforward to go build a WebSocket type of server for these event-driven architectures. So that all sounds pretty good. It's using HTTP2, and there are a lot of benefits there. So are there disadvantages? And yeah, are they actually better than a RESTful API? The design of these is a little bit harder to plan for. They can sometimes be a little more challenging to try to figure out, like, what are we going to do if they hold this connection open for a really long time? Should we rate limit that? What if a client tries to connect several times? Do we only allow one connection from a particular client? So those kinds of things can be a little bit trickier. And also for some of these things, when you connect to the server, some of that handshake that you do around this is how I want you to respond, it's actually like, hey, here's a URL that we want the server to actually connect to actually send its response. So you're basically saying like, hey, PayPal, I'm going to connect to you and say, let me know when a payment happens. And when a payment happens, I want you to go hit this other URL. Well, there are downsides to that as well, because there can be confusion about, well, how do we spin that up so that when PayPal hits us back, we've got something that can answer to that. Otherwise, PayPal is going to fail and something's not going to work correctly. And are we going to get the data that we expect? And so there can be security implications about exposing URLs and things like that for the server to do a callback. And so this is typically why the more popular way of doing this is to just have that long connection open, where you're saying like, hey, we might not talk on that phone for a while, but if something happens, we've already got that connection established and you can just tell me. Otherwise, what we would have had to do with a RESTful implementation is we would have to constantly connect to the server, say, hey, do you got anything for me? No? Okay, cool. And we would disconnect. And then we would call back and say, hey, have you got anything for me? No? Okay, cool. And we would disconnect. But every time we connect, we have to go through that secret handshake of this is who I am, this is me proving who I am, and doing the whole authorization and authentication back and forth. And so with the Async API, where you're just holding that connection open, you do that secret handshake one time, and then for the duration of that connection, everything is established. Now, if something happens and your internet connection, between the client and the server gets disconnected for some reason, you've got to go through that whole handshake all over again. Some other aspects of this get really challenging if you're trying to rate limit, like how many API calls can somebody make, because they've already established that connection and they're just going to keep sending information over that connection. And so tracking analytics can be a little bit trickier. Throttling your data can also be a little bit trickier. And some aspects of security can get a little bit harder when you're dealing with async APIs. So if we were to compare side by side RESTful APIs and asynchronous APIs, let's talk a little bit about what we've covered so far. So REST APIs are using HTTP1. Async APIs are typically going to use HTTP2 by default. Getting a response, we're gonna sit and we're gonna wait for that response. With async APIs, we can get notified through an event loop or something like that something has happened, and then we can go handle that. So for the design complexity, because RESTful APIs are very ubiquitous and typically straightforward and also taught more in education facilities, the design complexity feels a little bit lower because there's a lot of tooling out there, where on the event-driven side, it's a little bit harder to design. There's not as much tooling out there. So I'll be sharing these slides out a little bit later, so I won't go through and read everything on here. But the one at the bottom is the one that I kind of want to really stand out here when it comes to the data structure. Again, RESTful APIs on HTTP1, you're choosing text mode or binary mode, but you can't do both at the same time. Async APIs, because they tend to use HTTP2, they can send both text and binary data. So like if you want to send over an image or a stream of video data or something like that, you'll be able to do that with HTTP2. All right, well, let's talk about more performant APIs, because there are some downsides to REST and the event-driven things when it comes to how quickly things operate. And so let's talk about some performant types of APIs. So when we take a step back and we think about it, it's like, well, can't we just scale up RESTful APIs or async APIs? Like, can't we just throw more hardware at it, throw more money at it? It's like, well, yeah, you can scale these, absolutely, but it's often more challenging and it presents other information or other problems as well. And so are there technologies that can kind of take the best parts of REST APIs and asynchronous APIs and kind of combine that in some way? What if we could make an API that was also faster as far as, sending these messages over and decoding them and not losing our data types and things like that? What if we could allow for asynchronous calls, but also synchronous calls to kind of combine and, have some choice over that? And it turns out we do. So gRPC. So Google to the rescue. So the idea of RPC, or remote procedure calls, that's actually been around since like the 1970s. It's been around a really, really long time. And the concept of sending an instruction as part of connecting to a server and say, I want you to run this instruction, here's some parameters, and send me back a response. That's actually been around a really long time. But with the invent of the web and everything that we're transferring around the internet, Google said, well, why don't we do these remote procedure calls over the internet? And so we collectively, as Google basically said, we're going to create this new thing called gRPC. It's not the magic bullet that's going to like save everything though. But there was a lot of drawback to using XML for these remote procedure calls and sending over kind of these packages of this is what our data looks like I was talking about with the data types with XML transfers. With JSON data, there is like a binary version of JSON called BSON, which you can get into data typing, but it doesn't quite map very well all the time. And so with gRPC, they wanted to build this out in a way that we could do asynchronous calls or synchronous calls. You can do like, hey, just connect once, give me some data back, then we'll disconnect. Or you can do asynchronous calls where it's like, I'm going to hold this open and you can stream data to me, or we're going to hold this open and I can stream data to you and you send me back one response that you got everything. Or we can open a connection and we can both stream back and forth. So gRPC gives us a lot of flexibility as far as what kind of API calls are we going to make? How are we transferring that data back and forth? And it's also built with performance in mind. Typically, a gRPC API is going to be 7 times to 10 times faster. Then this mostly comes from the benefits of HTTP2, where we're getting into stronger compression. So there's literally less data to actually transfer in the data transfer between the client and the server. Because you're also sending things in binary format and not plain text format, it's also a little bit smaller. Plus, then you're compressing that. Plus the fact that because it's in binary format, the client and the server already know, like when I send this thing over, it directly maps into this structure of data where those data types are also defined. And so there's less ambiguity around, is this a number? Is it meant to be like a floating point number or an integer number, that sort of thing. So here's a quick example of what we call a proto file. And this is how you get started with gRPC. Within gRPC, you can basically define, I've got a service. In this case, I picked up this code from Google's actual gRPC tutorial website that you can check out. And basically, it had a couple of endpoints. And these are the 4 different kinds of calls that I mentioned. So the first one is just a single request and a single response, and then there would be a disconnect. The second one, I'm going to send you a single request, but I'm going to expect multiple messages back from the server. And this could be something like, hey, I need a catalog of images. So I'm going to send you a list of images that I want you to send me, and then you're just going to send all of those back as a stream of data. The third request that we see here is basically, I'm going to send you a whole bunch of data. So maybe my user is going to give me a bunch of images, and I need to send all of those to the server, and I want to get one response back saying, cool, we got all those images. And then the last one is, what if we want to stream data back and forth? Like maybe I want to send you a bunch of images, and then you're going to manipulate those images in some way, and you're going to send them back to me afterwards. Down at the bottom, we see what we call a message, and this is basically the way that you define, this is what a payload of that data is going to look like. In this case, this message is called point. And if you look at line 3 of this code, this is where we're basically saying, hey, this call is going to send a message payload using point. And so this is basically telling the server, when the client connects, you're going to get 2 32-bit integers in that data payload. And so it knows exactly how to map whatever you're sending. It's going to treat as 2 32-bit integers, so that the server already has that decoded on the other side. There's no guesswork there. The other nice thing about these proto files is you can split them into multiple files and they can refer to one another. And it's a really good way to sort of keep your code organized a little bit around how you're going to build out this API. So these examples, as I said, they're all from the grpc.io website. There's a whole tutorial thing that you can do there, and I grabbed some portions from that. So the nice thing about this is it's a pip install. You pip install grpc.io tools, and then from there you can basically call out from the command line. The -I is basically, here's another proto file that I want to include while you're processing this. And then you give it kind of some directory information of where you want to build out this code. And the last parameter is, here's my primary like root level proto file that kind of starts all of this, that references out all these other proto files. And basically, this will generate code for you. This generates both the server code and the client code for you, at least the structure of it, the skeleton of it. So it would be a little bit like if you're going to go build like a new Flask, framework kind of tutorial, or a new Django one would be an even better example. At a command line, you say, I want to build a new Django REST framework application, and it goes and it builds a whole structure of code, and then you just go in and you fill in the actual logic. Well, gRPC is doing the same thing. You define that proto file, and it's going to go build the client side software structure for you, but it's also going to build the client software for you as well. So if you want to build an SDK in Python to talk to your gRPC server, this code has just generated that for you. And so now you've got library calls in that client software. You include that as a module in your other Python software, and it's going to know how to communicate with that gRPC server for you. So then we just go in and we can kind of fill in our own logic. And then this last block of code here, this is where you go into your code and you say, okay, now I actually want you to be a server. And you add a little bit of code here that says, start this up as a server. I want to run 10 client workers to listen for these connections and handle these connections and so on, what port you want to use. And then you just say, okay, start, and then wait to tell me to stop, basically. And it's just going to sit in its own little loop, and it's going to run forever. This is about as easy as it gets. Auto-generated code. You write a little method, and you've got a server, and you're up and running. And by the way, Postman also works really well with these types of APIs. And if you bring that proto file into Postman, we'll also help you kind of plan out what that API is going to be. We'll let you kind of build out a collection in a hurry to actually go interact with your gRPC server just from that proto file. Because with the proto file, again, we can kind of compile what that client side connection is going to look like. But there are disadvantages to gRPC as well, because nothing's perfect, really. Adoption is still really low. The complexity is a lot higher. You have to do a lot of your planning ahead of time so that you can generate that code, so that you can fill in the code to actually do what you want it to do. And so you have to spend a lot more time on the design before you ever get into writing the code. Sometimes that's a good thing, though. Like when we talk about API design, we talk about a term that I mentioned earlier in the talk called governance. And this is where that governance is really going to come into play, where you're talking about the design of the API, what your payloads are going to be. You get into building out your API contracts and so on. It also relies heavily on HTTP2. It uses HTTP2 by default. And because that adoption isn't, used everywhere yet, the adoption of gRPC is also a little bit slow. HTTP2 as a protocol also has some downsides. So they've actually started proposing HTTP3, which is going to fix some of this as well. Eventually, it's going to take time because any new protocol takes a long, long time to come into play. And third-party tooling is still fairly new. Now, the team that works and builds on gRPC, they've done a really good job with that code generator. There are other tools out there that will help generate code, generate documentation. There's a lot of good stuff out there that you can use, but it's still relatively new. It can be buggy, and so there are some downsides and roadblocks in there as well. So those other generators do exist, but they're still fairly new. So let's compare REST APIs then with gRPC APIs. So again, the data transfer is happening over different versions of the HTTP protocol. But getting a response with a RESTful connection, I make that connection, I wait for a response, and then we hang up. Where with gRPC, we get to choose, are we going to do this synchronously? Or are we going to do it asynchronously? Am I going to send you a stream of data? Or are you going to send me a stream of data? So you've got a lot of flexibility there. But it does make that design a little more complex because you've got to go through, you've got to plan that whole thing out. You can go in and you can add code after the fact, but the auto generators are really, really nice that kind of go build that structure for you. So there's less manual work that you have to do to go in and build that. And so when it comes to typical use cases here, we would see a lot of gRPC APIs typically happening between servers, not so much as a public facing API. So the nice thing about REST APIs is, because we've been building these up for quite a while in our industry, there are a lot of public-facing RESTful APIs. With the event-driven architecture and the event-driven way of doing things, we're seeing a lot more of those as public-facing APIs. Excuse me. But we're not seeing very many gRPC public-facing APIs. There are a few out there, but they're not as common. Like I said, they're typically done between servers or mobile apps. So if you're doing a lot of like mobile banking and things like that, that may happen over gRPC because your mobile client can implement whatever library they want to use as they're connecting to the server and communicating with the server. So you'll see it a lot in mobile apps, as well as like things like event logging and monitoring tools and things like that. All right, so can't we just do all of this to make RESTful APIs? Like, why do we need to bother with, event loops and event hooks and getting into things like gRPC? Like, can't we just do all of this in a RESTful API? Can we implement REST on HTTP2? It's like, well, yeah, you can if you want to build that out. But again, you've also got to build the infrastructure of, okay, well, we have to like make sure the HTTP2 is enabled on all of our things. And that's not just a software configuration change, it's also a DevOps change. Can we use a binary format to send that data over that enforces sort of these data types? Well, yeah, there's that BSON version of JSON that you can use. Or you can mimic, the payload, because a RESTful call can transfer data in binary. So yeah, you could do that. But you have to make sure that every client out there knows that you're sending binary data. They have to be able to process that on their side. And do you really want to have to get into writing client libraries to be able to talk to your API? It's going to increase the complexity of everything that you do kind of overall. The nice thing about gRPC is there's kind of a discovery sort of built in with this proto file where you can connect to a gRPC server and say, tell me all the different things that I can call, tell me all the different kinds of message types, and the client automatically knows about everything that it can do. Where with RESTful API, there's no real cataloging system to be able to do that. So can we build out like an event-driven type of architecture using REST? It's like, yeah, you can, but it's still typically a single request and a single response type of cycle, mimicking a stream of data. It is possible, because that's how we've done a lot of streaming data over the the last couple of decades. But it's not a fantastic way of using REST. Well, can we do more encryption by default? It's like, yes, please. You should be using encryption by default nowadays. So please, by all means, go ahead and encrypt your data. But what about compression? Can we introduce something that's more, that compresses better or faster than gzip? It's like, yeah, you can, but it's already built into browsers. And so if you're building a JavaScript connection to a server, you're going to have to implement that compression technique in a JavaScript library. And that's going to add overhead because that compression code is actually going to run on my browser or your browser. So it has to be super fast for low power devices to be able to handle that compression algorithm as well. So yes, there are ways that we can mimic a lot of the benefits of event-driven APIs and things like gRPC APIs for streaming data. We can mimic a lot of that in a RESTful API, but it drastically increases the complexity of what we're going to build. It increases the complexity of the architecture of what you're doing. So is it really worth it? So it really comes down to how do we choose which kind of API that we're going to build? And it really comes down to a balance of performance. But what does performance even mean? Well, performance comes in two forms. One is the team execution, and the other is the actual software performance and the network latency of how performant is your API going to be. As a previous hiring manager myself, I'm a big fan of letting my team learn some kind of new technology. But if we've got a deadline, we can't always dabble in the latest and greatest. Sometimes we have to go back to what the team already knows, or we've already got infrastructure to handle this kind of thing. And so how quickly can the team build something, or how quickly can the team build something? It's kind of the same question, but it's like, can my team build this thing in a hurry? Like we have a deadline. Can they do it in a short amount of time versus can they build something that's performant? Can they build something that's going to be fast, as far as latency times and the compression of your data and how much data are you sending, things like that. So does your team already understand these technologies? Is your infrastructure already set up for these technologies? Is there an easier migration path if you want to like change this out later on? I've actually seen some people write APIs around their APIs so that they can kind of change under the hood what the core API started out as. So if you're building, say, for example, a REST API and you've had that in place for a while, and you say, okay, well, now we want to build that out as an event-driven API, or we want to build that as a gRPC API. Well, you don't want to break everybody else that's already connecting to your API. And so I've actually heard of some companies that they build like a wrapper around their API, which is another RESTful API. And it's kind of like a wall in front of it. So any new connection coming in, they think they're still connecting to a RESTful API, but under the hood, they're starting to change the inside of it. So think of it a little bit like a butterfly in a cocoon, right? From the outside, it's still a butterfly in a cocoon, or it's still like it's a cocoon. I know I'm interacting with that cocoon, but what's happening inside? Is it still a caterpillar, or is it a butterfly yet? We don't know, right? We're just interacting with that cocoon. And so it's a little bit like that. So they kind of shield their API. Meanwhile, they rewrite the API on the inside. And then once it's done, they kind of take away that outer wall. And so while you're building that out, it does increase your latencies a little bit, but it also reduces what we call breaking changes and allows for a better user experience when it comes to those APIs. So this is just a bit of an exploration around different kinds of APIs that you can use, showed a little bit of code that you can do in Python. But when it comes down to which one do we choose, it's really going to come down to what is your company comfortable with? Are they comfortable with spending some time learning some new technologies? Because there are some much more performant types of APIs out there than REST. There are a lot of interesting things that you can do with event-driven architecture that you can't easily do within REST. So the answer is it depends. Which API do we choose? It depends. It depends on a lot of things. But I wanted to educate a little bit and share some of those thoughts with all of that. So thanks for your time. My Twitter handle's at the bottom of all these slides, and I'll share the slide deck as well. My bio on my Twitter will also link to my Mastodon account through Linktree. So if you want to connect with me on Mastodon, I'm happy to do that. And I also use the same username on platforms like LinkedIn and Twitch. On Twitch, I also do live programming on Tuesdays, where I actually get into my Python chat bot, which is using asynchronous APIs and lots of webhooks, as well as RESTful APIs. So I'm writing a whole chatbot that interacts with a lot of different kinds of APIs. So you can come watch that as well. Shameless plug. Thanks for having me today. I'm happy to take any questions either on Slack or on Zoom chat. I'm happy to hang out for a little bit, or you can reach out to me on Twitter if you've got other questions about how to interact with that, or you got questions about how to do this inside of Postman. I would love to sit down with you and have a conversation about it.